Back in 2018, I bought a kit from Open Builds for a machine called Sphinx. And I put it together, and it was a really cool little platform that I've used for about a year. I had a great learning experience with it. I learned the ins and outs of CNC, routing, at least the mechanics of it, and I was able to get some solid works done with it. And overall, it was a great experience with the Sphinx. Then I started to mess around with aluminum at some point, and I decided I wanted more rigidity out of my machine, and I started looking for options on how to get more from my platform. After browsing around for options, I decided to go with an upgrade to linear rails and ball screws using my existing frame from Open Builds. I found a great thread of how to do it on Open Builds website by Troy Proffitt. I decided to pursue a similar upgrade on my machine as well. At the time, I might have been a little bit naive in terms of what it takes to put this kind of a build together, the planning required and the alignment needed to get all the parts to play nice together. I went right into milling aluminum plates based on Troy's plans, but I didn't really make sure everything lines up and matches the geometry of my build. And so I had to struggle for the longest time with alignment issues around how to get the motors mounted. And I also went with the end mounts for the ball screws on the outside of the plate, which was a huge mistake. It drove a ton of placement and alignment issues. I had to create a connector plate. I had to re-drill many of my holes to get things to work. And in the end of the day, that machine did work, but it wasn't straight. It wasn't perfect, and I could see the motors struggling and rocking around when moving, and I was definitely limited in my feed rates because of this. And when your ball screw is not 100% straight, you will see a degradation in your performance, no doubt about it. So it was befitting for a brand new build that you just put together after a year's worth of work. I decided to rebuild the machine from scratch. This time I didn't skimp on the planning process. I planned the whole thing from scratch. I put it together in Fusion. I made all the parts join and mate in Fusion to ensure maximum accuracy after I cut the plates. And so on I went and started milling the plates on my new upgraded machine. It was substantially easier this time as compared with using the out-of-the-box Sphinx kit for sure. The additional rigidity made it substantially easier to cut the plates. My feed rates were substantially higher. My cut depth were deeper. I was able to get the thing uh, cut relatively fast. Okay, so to start the build, I had to source a couple of components. I had to get longer C-beams to fit my longer ball screws and enable me to mount the end supports on the inside. I also bought three V-slots that are slightly longer than what I have before in order to extend the base of the machine to fit the new C-beams and the longer ball screws. So all the geometry works together. You can see them on the left. These are the silver parts. In terms of the rest of the hardware, I basically reused whatever I had. You can see the high wind rails on the right, the carriages, and the end supports are the existing ones. I chose this time to only upgrade the X and the Y axes. You'll see that I don't touch the gantry itself. The gantry with the Z has been stable and generally well aligned, so I decided not to touch it right now. Okay, so first stage. So the first stage that we are going to go through is upgrading the base frame of the machine. Again, the base frame before was built for 500 millimeter C-beams. I now have 565 in length. So I need to replace the rods or the V-slots that go in the middle in order to get the new C-beams to mount in the right length. Okay, so this stage is pretty straightforward. These V-slots you're seeing connecting between the two long V-slots here are held together with a few screws and angles of going to T-nuts. I'm just basically screwing them out replacing the existing ones and mounting the new V-slots in place. This will extend the base from 500 to 565 millimeters. Now that we have the base together, the next thing to do is to get the C-beams mounted to the top of the base. What we do is we put T-nuts on the extrusion underneath the C-beam, and then we mount it through the angles that are bolted to the base. Later on, I use these angles to adjust the position of the C-beam to get it dead on straight once the rails are on it and everything is mounted together. Once the C-beam are mounted, the next step is to get the high wind rails to align on the C-beam as to put it in place. It's mounted using T-nuts. These are, I think, M4 T-nuts, going with M4 nuts through the rail. You basically slide them into the extrusion. Make sure you got the right rail in the extrusion because there are two rails, and I always get the wrong one and have to then disassemble it and get it all together again. You put one on each side. I don't think we need to take too much care in terms of aligning them at this stage. There's still a ways to go before we have to get the final alignment to get in place. Okay, once the C-beams are mounted and the high wind rails are on them, I just make sure they're perpendicular to the base itself, and I kind of make sure that they also are with the right distance from one another. They're looking to be 95 centimeters or 950 millimeters. Again, not down to the millimeter at this stage. It's too early. There's too much misalignment. The base of the frame is now done. It's time to mount the carriages onto the frame or to the rails. I have 4 carriages, 2 for each side. First thing I want to do is put some grease in them to ensure they go on smooth. It's a bit harder to get to the lube zerk later on if you don't do it in advance. So you can see I'm doing it beforehand, and then I'm gonna just mount them onto the rails. Mounting the carriages to the rail is not rocket science. It's really pretty straightforward. You have this plastic thing that sits inside a carriage. You just need to make sure to slide it onto the rail while you put it together with a sliding motion. You don't want to have the plastic outside without anything supporting the bearings inside the carriage, or they might fall out and you're in for a world of hurt. I've had it happen to me in one of the ball screws before, and after a day trying to fit the bearings inside the ball screw, I went out and spent another $100 and got a new one. So trust me, you do not want to have them fall out. It's pretty straightforward. You position it at the end of the rail, and you just slide it on while you let the plastic part slide out. With the frame and the carriages all in place, it's time to start looking at the gantry. I mentioned before I'm not going to replace the actual Z or the gantry part itself. What I am going to do is try and keep the existing structure, but take out the previous plates that were holding the gantry on the right and left hand side, and get the new plates mounting on. So again, not touching the extrusions, not the rails. It's just a basic switch of the plates. So here you have the new plate laying face down there, and the old plate still mounted to the gantry extrusions. You can see also that in order to get the ball nut housing to connect to the old plate, I had to create a connector plate. This is again because of misalignment problems that I had. One more step before mounting the plate is to connect the end support using M5 40 millimeter screws. I threaded the holes on the plate so it's easier to mount and not have to use lock nuts on the other side. I'm using 4 M5 25 millimeter screws here. When I bought the extrusions originally, I cut them to the wrong length. I put them at 998 instead of 1000 millimeters. So now I have the bonus or pleasure of having to mount a shim between each one of the screws and the extrusion. I played with a couple of options on how to do it. In the end, I just flipped the plate on its side, put power shims on it, or H shims, and then just carefully aligned it and drove them in. At this point, I went on and mounted the X-axis ball screw. This is the long screw. I threaded through the ball nut housing at the bottom there, and then I match it or put it through the end support on the right. Now, throughout this build process, I had this lingering concern of having missed something in the plan or things not lining up right. So I'm putting in the end of the screw here, and it was at this point that I'm looking at the other side, and I'm seeing that the ball nut housing is 7-8 millimeters off to where the screw is. Take a night off, I give it some thought, and then I remembered that I had to create a connector plate behind the Z-axis before in the previous build because I had issues with misalignment of my screw. So now that connector plate that's sitting underneath my gantry is driving the ball nut housing out of alignment from where it actually should be. I removed the connecting plate or this adapter that I had to create before from underneath, and now I have the ball nut housing mounted directly to the gantry plate, and everything lines up real nice. Now, when I bought this ball screw, it was meant to be mounted with end supports on the outside. Now that I'm putting this with end support on the inside, on the left-hand side, you will see that the ball screw is protruding quite substantially to the left. I wasn't about to get a new ball screw, nor did I want to get new extrusions and new rails and extend the base of the system of the CNC. So instead, I came up with this idea of creating an extension of the end support on the left-hand side. I didn't think it would matter that much if it protruded on the left. The support would be the same support, even if I have this connector plate. I cut one just matching the profile of the BK15. It wasn't enough, so I took an older BK15 frame or end support without the bearing inside. And when I mount both of them, and bolt them to the plate, I can then have my original end support mount to the end of the screw comfortably and provide the support required to get the screw turning. Now, this wasn't the end of the complications I had with my ball screw. When I bought it, the tolerance on these Chinese screws wasn't perfect, the bearings, and it's just, they don't fit well. It's really hard to put them through the bearing. I had to really hammer it in at some stage, which was not acceptable. Right? So what I decided to do, not having a lathe, is to fabricate a manual lathe. The way I did it was to lay down a cordless drill on the other side of the screw, and I had like a zip tie holding it in a working position and have the screw constantly turning. So then I went on the other side and I took fine grit sandpaper and this is wet sandpaper, and I just hold it in place and let the screw grind against it uh, very finely, very gently, just to file a very thin amount of material until it fit the bearing. Now it was all about getting the nut into the nut housing underneath the Z plate in order to make sure, when the screw turns, that the whole assembly moves right or left. Okay, now we move to mounting the nut housing that rides the y-axis on the side of the plates. I'm using a half an inch countersink bit to enlarge the holes just a little bit on the inside so that the heads of the screws don't protrude and scratch or touch the sides of the C-beams later on. The nut housing itself is secured to the plate using four M6 screws. They're 30 millimeter in length. You drive them through the plate and into the nut housing itself. Okay, now it's time to mount the Y-axis ball screws. There are two sets of ball screws and connecting plates. So you connect a plate on each side of the C-beam, and then with the end supports on the inside, you have to thread the ball screw through the gantry nut housing and mount the whole thing together. You'll see it's a little bit of a fiddly process, but not a really complicated one if you plan it right. Now, the fun part with the design of the Sphinx is that the Y plates have four T-nuts that connect to them to the base, to the V-slot on the base. So you basically have to get the four T-nuts into the V-slot as well as get it mounted to the C-beam while you thread the ball screw in place. This was it took a little bit of playing around to find a process that works. In the end, what I did was to get all four T-nuts mounted or placed on the plate, and while I put the screw in place, I slid two or three of them in position, and then the last one I just tightened on the rail itself. You'll see it as part of the process here. Okay, so here's the process of getting the ball screw in place. I first of all I mounted it to one side of the end support. You see the back one over there. What I'm going to do now is slide it through the ball nut housing, mount it to the end support on the other side, and then screw the whole thing in place. I had to think about it a little bit to find the process that gets all um, the angles just right to. Yeah, this is the fun part I was mentioning before about having to slide the T-nuts into the base extrusion while having the ball screw in place to mount. So you can see the T-nuts in the bottom there, and I'm trying to get them to align to the rail while I'll put everything together, and then I slide them in, lock them in position, and take it from there. And now we get the end support mounted to the y-axis plate using four screws. I'm taking extra length here with the screws so I can have nuts on the other side. I wasn't able to thread one of the plates, so I'm just for symmetry, I'm mounting them from the external side or from the outside in. It makes no difference. It's just an aesthetic choice. Now rinse and repeat on the right side as well. In terms of connecting the arm plate to the Y carriages, before in the past I was using an angle. That angle was very inaccurate and I couldn't really get it to mount right. So what I decided to do this time, I cut two plates. Again, same aluminum, and these have the hole patterns that match the carriages. They fit to the left-hand side or the right-hand side of the arm plates, and I would drill into the side of them and thread them, and then have them connected with four screws from the arm plate. These carriage plates are mounted to the carriages using M4 screws. The problem that I had is that the holes that I made for these M4 screws were slightly on the small side. It felt like the screws were threading in. I wanted to ensure a good, easy fit, so I re-drilled them using a 4mm drill just for easier mounting later on. Now that the carriages are connected to their plates, I match it, or I put it sideways to where it fits the arm plate. I'm going to clamp it in place just to make sure it doesn't move on me. And then I'll use a center punch to transfer the middle of the hole into the side of the plate accurately. Okay, now it's a matter of drilling 4.5mm holes at the side of the plate where we center punch them, and then following on with threading them to 5mm for the screws to fit in later on. Here starts a pretty tedious process of connecting and bolting the nuts to the nut housing using the M6 screws. I bolted it, and then I noticed the screws were turning a little bit rigid, So I disconnected it, took it apart, realigned the C-beams a bunch of times, connected it back. It took a couple of hours to get it just right and to feel like it's moving smoothly, but I think it was worth the effort. You really want to have the screws turning as easy as between a couple of fingers. You don't want to have work for it because if you have to work to get the screw turning, then your motors will be investing effort where they shouldn't. The motors mount to the external side of the plate. Obviously, I use spacers. I just find the right spacer for each motor. It depends on how the screw turned out to be. It could be 40, 45, 35 millimeter. I have spacers of all sizes from previous experiments. It's a matter of find the right size and just screw it in position and lock the collar on it. Okay, and here she is. 4 motors mounted, spindle in position. You can see this is the X motor, right Y, left Y, and the Z mounted in place. Right, but for the Z we didn't make much of a change, but everything's mounted in place and is ready for first movement and testing. First movement test, taking it slow on each one of the axes to see that everything is turning and working as it should. Doing the X, then Z, and then Y. Of course, I am cheating a little bit because I had the previous test that failed because the coupler was grinding on the right motor on the Y. When it happened initially and the Y wasn't moving as it should, I almost jumped to my death from my chair. In the end, as I've tested the X and the Y to move up to 5,000 millimeter per minute. This is 3.5x what I had before when things were misaligned. In the previous build, I had a single 1-inch MDF sheet serve as the spoil board, and after a little bit of this, it looked like this. So this time I decided to go with multiple pieces of MDF mounted onto a single sheet of quality ply, right? So you can see that I have a single sheet of about half an inch maple. I bought an expensive, relatively expensive ply to make sure it's straight and it's level. It's there. It's hopefully going to stay there forever. And what you do later on when your spoil boat goes bad, you replace the MDF sheets that are mounted on the plywood. This gives you control in case one of these planks, or maybe even all of them, go to waste. You either resurface them and mount new ones onto the same sheet of ply, or you replace, you know, as many of them as you need. MDF is super cheap. The whole amount of MDF that is currently mounted there costs like I think $10 or so.